Hi, everyone. It's Kira Garfolo again with Math 109 at Greenville Tech. Today, we're going to talk about section 2.1, which is solutions of linear equations. Some of you may have seen this before, so if so, you'll enjoy this section and it'll be nice and easy. And others of you, it may all be new, but don't worry, we'll have plenty of practice. So first, we need to do a little bit of an algebra review. Recall that when we're solving equations, we want to isolate the variable that we are solving. So if you're solving for x, you want x to be alone on one side. If you're solving for y, you want y to be alone on one side. And the same applies if you're doing for t or g or z or any variable you can think of. Excuse me, guys. I've taught too much today, apparently. So that's simple enough, except when there are fractions involved, they can look really ugly and tricky. Remember that if there are fractions in the equation, the easiest and simplest approach is going to be to get rid of those fractions before you start moving things around. The easiest way to do that is to find the least common denominator, the LCD, multiply everything by that value, and then solve as usual. So let's look at an example. We want to solve for x. We have x plus 3 over 4, quantity, minus 2, equals the quantity x minus 1, all divided by 5. To solve for x, the easiest thing to do is to start by applying the lowest common denominator. So 4 and 5 have a lowest common denominator of 20. So we'll multiply the left whole side by 20 and the right whole side by 20 to get started. When we do that, we end up with 5 times the quantity of x plus 3, and then minus 40, because 20 times negative 2, and equals that 20 and that 5 reduced down to 4 times the quantity of x minus 1. If you're rusty on this type of math, our textbook has an algebra toolbox section at the beginning of each section in the text, and I believe that this chapter's algebra toolbox will certainly be your best section for that. If you need more practice, let me know and I'll find exactly where it is in the textbook. We're ready to solve for x like usual. I like to distribute everything across my parentheses first so I know exactly what I'm dealing with, and then I just combine like terms. I end up with 5x plus 15 minus 40 equals 4x minus 4. Combining the terms on the left that are constants, I end up with 5x minus 25 equals 4x minus 4. And if I bring the x's to the left and the solids to the right, I end up with x equals 21. Please take a moment and be sure that you can work this out. You'll see something like this on your homework, but also it is crucial for not just this section, but anytime we're dealing with fractions in our course. Now, this looks like a lot of words and instructions, but it's going to be super helpful and it's more there for your reference. We'll walk through it with an example too. Okay, so to use our calculator, the first thing we're going to want to do is move everything to one side of the equation, so it's equal to 0. So all of your constants, all of your x terms need to go to one side so that all that's left on the other side is 0. Then that non-zero side is going to go into the y equals in your calculator. Then we're going to use the 0 feature of the calculator, which is found similar to where we found what we used in the last section. You're going to use the 0, and remember there that your left bound is on the left side of that intersection and your right bound is on the right side of that intersection. Let's look at an example. So we want to solve for x, and 5.72x equals 1.78x minus 15.76. This is simple enough to solve algebraically. You can put the x's together, and then you just divide that 3.94 away, and you get x equals -4. But we want to do it with our calculator also. We'll confirm that x equals -4 in a moment. So let's solve it graphically using that zero method, the x-intercept method. So remember that first we need to move everything over to that left side. So 5.72x minus 1.78x plus 15.76. Now you may notice here that you could combine those like terms just like if we were solving algebraically, and you're welcome to, but you certainly don't need to because our calculator is smart enough to do it for us. If you want to combine like terms, I would just encourage you to be very careful, because if you make a mistake there, then you'll get a wrong answer and it won't be really, there was no benefit for simplifying there. So let's go ahead and put this into our calculator. We need to go into y equals, and we have 5.72x minus 1.78x plus 15.76. And now we'll just graph that. And this is a linear function, so we have a complete graph here. We see the intercept, although technically it's not fully complete because we can't see that y-intercept, huh? But it's got everything that we need to see because we need to see the x-intercept. If you were asked for a fully complete graph, you'd want to zoom out a little bit or use a wider window on your y so that you can see where it hits that y-axis. Okay, so once we're here, we're going to go to second calc, and we want to calculate a zero. So remember that we want our left bound to be on the left side. So we're going to trace way down there. You can type it also, but I like to use trace because I like to see exactly where it is. So our left bound, sure, that works. That's on the left side of it. We'll press enter. Then we need to go past our intercept to the right side and say enter. And it's going to say, hey, you want me to guess? And you're going to say sure and press enter. And it's going to say, hey, your zero is x equals -4 and y equals 0. The solution here is where x is. So x equals -4. If we go back here, remember that algebraically we solved x equals -4. So that's good. We confirmed our right answer. Here are some pictures of exactly what you needed to look at and what you needed to see, just for later reference, so you don't have to flip through this whole video. Now, a lot of people really like the zero method. I personally prefer this other method. It's also with the calculator. It's just something that I think is cooler to look at. It is the intersection method. So now, instead of pulling everything to one side, you're going to put the left side of the equation into one equation, and you're going to put the right side of the equation into another y equation. And then you're going to use, instead of going to zero, you're going to choose intersect. And intersect's going to ask a few different questions than zero did. It's going to ask us a first curve and a second curve and a guess. So on the first curve, it should be on one line. It doesn't really matter which one. The second curve, it needs to go to the other line. And before it guesses, you want to be close to it, okay? Somewhere on the screen. It doesn't have to be right on it. You don't have to zoom way in, but somewhere right there on the screen. So let's give that a try with our previous problem. We know that we have 5.72x equals 1.78x minus 15.76. So if we go back into our calculator, back into y equals, we're going to clear our original from last time. And we know that we have 5.72x here. That's all that's on that left side. And then on the right side, we want to put the other equation. So we had 1.78x minus 15.76. Now when we hit graph, we'll see this. Now this is not a complete graph. We can't see all of the intercepts. We see it for one, but we don't see it for the other. We don't see the Y for the lower one. And we also don't see where they intersect. So we need to zoom way out. Let's see. Let's do a minimum. The X I think is fine. It's the Y that we need to work on. So let's do a Y minimum. Instead of -10, let's try -20. I hope it's going to yell at me because I used my keyboard. Remember, negative is that negative sign, not minus. Now let's go back to the graph. We're getting closer, but we're still not there. So let's zoom out even further. Instead of -20, we'll do -30. That should get us there, I hope. You're not the only one that has to play these games, see? And voila, there it is. They intersect. They intersect right around here. So now we don't care so much about the zeros, but we want to see where they intersect. So we'll press second, calc, and the option here is intersect. Keep in mind, if you have a TI-83, this is a simulator for the 84, and so sometimes the numbers don't line up, but you will still have these options. So just pay attention. So we'll choose 5. See how the first curve is highlighted on this other curve, the upper curve? So sure, that's one of them we want. And then the second curve, we just want to make sure it's on that other one. So sometimes I move back and forth like this to make sure. And yes, that is what I want. I press enter. And then for the guess, I'll usually just make sure it's somewhere near there, okay? And you'll press enter. And it says, hey, they intersect at -4, -22.88. Now remember, we're solving for X here. We don't particularly care what Y is. We only care what X is. And just like before, our answer is X equals -4. That's the same that we found here algebraically. It's the same that we found with the zero method. And it's the same that we found with the intersection method. Now, sometimes you'll be asked to solve algebraically, and sometimes you'll be asked to solve graphically. And unless you're given output like this, like I think your quiz gives you some pictures of the intersect, you're free to use whichever method you prefer. As long as you get the right answer, they're doing the same thing, just slightly differently. As an additional helpful hint for your homework, in any function, remember that the term 0 is the same as an x-intercept. That should make sense because we used the 0 function in the calculator when we were finding those x-intercepts. It's also the same as saying what value of x makes f of x equals 0. So the solution to f of x equals 0 is whatever your x-intercept is, or whatever your 0 is. All three of those things are the same thing. So if you watched this far, you should get the reward in homework, right? In homework, there are questions that ask for all three of these things. There are 3 points associated with it. Probably going to see the same thing on a test or a quiz. If you have found one, you have found all three. They are all the same value. So earlier in our example, we had x equals -4. We could say that x equals -4 is a 0, which is the same as saying it's the x-intercept, which is the same as saying f of x equals 0 at x equals -4. There's one other thing that is added to this section, and then we'll be done. We say that y is directly proportional to x if y equals k times x for some number k. Don't get bogged down by the symbols here, okay? If you can multiply x by some number and get y every time, then this is a direct proportional relationship. The value of k is called the constant of proportionality, or the way I usually call it, the constant of variation. So whatever you have to multiply x by to get to y is going to be that value of k, or that constant of variation. Let's look at an example. Suppose your little sister babysits in the neighborhood. When she works for 3 hours, she gets $24. We want to first find the constant of proportionality. Remember, this means we need to find k so that y equals k times x. Y here is 24. So 24 equals k times 3. She's working 3 hours, so that's our x value. So we know that 24 equals k times 3. Now you should probably be able to do this in your head. And that'll tell you that k equals 8. So then we know that y equals 8 times x, which allows us to answer other questions like this. How much would she get paid if she worked 5 hours? Well, now we've already done this. We know if she works 3, she gets 24, so k equals 8, which means that y equals 8 times x, and now we have x equals 5. So y equals 8 times x, y equals 8 times 5, which gives us 40. So we know that she would make $40. Direct variation and constants of proportionality are fairly simple. You just have to find what you're multiplying x by. Okay, well, that is all that we have for section 2.1. Relatively short session today. I hope everyone has a great rest of the day. And remember, if you need any additional help, don't forget the resources in Blackboard, the departmental lecture notes, any of the videos and resources from your textbook. You can also reach out to the Math Center at any time, and you can see me in my office hours or shoot me an email. Have a great one, and thanks for tuning in.